Hi guys, welcome back. This is continuing on your notes for section 1.1. So I just want to show real quick, I should have done this in the first section, what your notes will look like. So these are the notes you got in your packet, and I'm just going to separate. So 1.1, you can see they are all listed up top. Here's 1.1, and then up top, if I can get my camera to focus in a little bit better, here were all the vocab you should already have had filled in. All right. And now here's the core concept. When I flip my screen back to the book screen, so here was the vocab in the beginning where you can write everything down. And now we're actually getting into the lesson. So now you can see it, the vocab's in yellow, that matches up. So you can read all that. The core concept here is the core concept that we have on your notes. And the core concepts are always a big deal. And we're going to start with looking at this. So the first core concept, there's property of equality and subtraction property of equality. We have all these different properties of equality. Really, any function you can think of, remember how I called them verbs? Any verb or any function you can think of in equality, it can be done. And if it's done to both sides, then the result will be the same. All that means is, like when you look here, if A equals B. So these properties of equality will make perfect sense as we go through. So it says if A equals B, correct? So let's use something we know. 3 equals 2 plus 1. We know that's the same. A can be anything, B can be anything, okay? So this anything is 3, this anything is 2 plus 1. If I add 4 to both sides, well, doesn't it make sense if A equals B, then A plus 4 would equal B plus 4? Over here, it's going to be true. We're going to do the same thing to both sides. 3 plus 4 is 7. 2 plus 1 plus 4 is 7. Okay? That's all the property of equalities means. In this case, it's the addition property of equality because what did we do? We added to both sides. So whenever you say I blank to both sides, you are in fact using a property of equality, and you are using that specific property of equality. And it goes on to subtraction. So now you can see, if we think about same concept, if A equaled B, if I took the same amount from both sides, let's say, so now we still know, I'm going to pick new numbers just to make it easier. We know 5 equals 2 plus 3. If I subtract 1 from both sides, doesn't it make sense that A minus 1 would equal B minus 1 or anything? A minus C would equal B minus C if C is just some number. Well, over here, I'll subtract 1. 5 minus 1 is 4. 2 plus 3 is 5. Minus 1 is 4. It checks out. So whenever you're thinking about properties of equality, what these things are going to be, they're going to be our reasons for our steps of solving these equations, okay? Some of you guys have already seen this. Some of this guys, this might be new. So these concepts is what's going to drive our ability to solve equations, okay? And let's just jump right in. Excuse me. So now in your notes, you had the concept, the core concept. And I promise you our notes will go faster in the future. Right now I have to cover a lot of the things in the book. We just went over the core concept. Now we're going to apply that concept as it goes to a couple equations, okay? So how to solve these equations. And since that thing's flashing so bad, let's just use this. Now, your book has a narrator. If you like their voice better than mine, which I won't blame you, you can use. Or you can click down here to the click-through examples, which is what I'm going to be using to explain this stuff. And as we go through the click-through examples, I will be explaining it. So you can see this is actually your example A in your book. So we have x minus 3 equals negative 5. The whole way to work through this, and actually I'm going to work through this by hand first, and then go back and do the book example. I want you to see it twice. I want you to see how I think through things and how we will be explaining things. So here is that problem, right? Sorry, there's a little bit of a glare. X minus 3 equals negative 5. I put that line down the middle to show the left side is equal to the right side. Red was the original problem. And blue is what I'm going to do to both sides. So I have terms. And if this is a new concept to you, a term is a thing. If it does have a coefficient. Remember, it has an invisible coefficient of 1. So I have 1x minus 3 is equal to negative 5. I want to get the x alone. That is the entire point of this. You can think of it as a riddle. How do I get rid of it? Well, how do I get x alone? I have to get rid of that negative 3. It's a minus 3 when I talk about it, but as a term, there's two terms. I have an x and a negative 3. I want to get rid of that negative 3. Well, we already talked about what's the opposite, what's the inverse operation. How do I undo minus 3? To undo minus 3, I add 3. If I do it to one side, I have to do it to the other side. And that was the property of equality that says if I do it to one side and I do it to the other side, the result will be equal. Well, we should know minus 3 plus 3. You can say cancel, undo, annihilate, all those things. Those are gone. On the left-hand side, I'm left with just x equals, and I apologize, for some reason the camera's flickering. Negative 5 plus 3 is negative 2. And we are completely done with that problem. This work needs to be shown. I know a lot of you guys can do this stuff in your head. That's not the point. You have to show your work now because later on the problems are going to get harder and you have to practice showing your work. If you don't want to show your work, all I can say is you're not going to get all your points in your notes. You're not going to get all your points on your homework. Okay? Non-negotiable. It's just how it is. So make sure when you're doing your homework and your notes at home, show these steps because you're going to have to scan your documents and send them to us. Okay? So with that being said, now let's look at their click-throughs. You'll see it looks a lot like mine. So as we start clicking through, we're looking at the solution. So first you write the equation, which we did. Here is the property of equality, and we're using the addition because we're getting rid of minus, right? And after you add it to both sides, you simplify, which just means negative 5 plus 3, negative 3 plus 3, combining like terms. Hopefully simplifying expressions isn't new to you. If you need help on that, please let me know. But now we're at x equals negative 2, solved. And you check, because remember, the solution to an equation is that which makes it true. So is it true to say negative 2 minus 3 is negative 5? Yeah, because negative 5 is negative 5. We have a solution, okay? Now let's look at the next one. I'll just use the click through to explain it. I'm not going to write it on the board just to save time. I look at this. First, I'm going to look, okay, so 0.9 equals, or 9/10, however you want to say it, 0.9 equals y plus 2.8. I need to get y by itself. I need to think what is happening to it. And you could draw that line right down here. What is happening to the y? It's being increased by 2.8. So to undo, inverse, cancel, however you want to say it, plus 2.8 is to subtract 2.8. Now we're going to use, it says addition property, but this should really be subtraction property of equality. I don't know why the book is wrong on that. So we are going to subtract 2.8 from each side. 0.9 minus 2 is negative 1.9. These cancel out, inverse to 0, however you want to say it, and I'm left with y. And it doesn't matter which side your answer is on, negative 1.9 equals y. Now we want to go back and think, okay, how can I prove that? Well, if I can plug this, substitute this in place of y, and this makes a true statement, then we have our correct solution. And let me see if I can move my box. There we go. So does 0.9 equal negative 1.9 plus 2.8? Sure does. Correct solution. And hopefully some of you guys get that will help you when you take multiple choice tests. You don't always have to do all the work to get the right answer. You should be able to do the work, but you don't always have to. All right. Now, after the click-through example, you're going to see you go to something called monitoring progress. These are practices in your book. I will not physically be doing these on here, but I'm going to run through one just to show you. So when you hit start, it'll think for a second, then it'll call up the problems. So you have to solve them in here. So n equals, so you'll solve it, okay, and then you can do you should be showing all of your work, okay, and then you type in your answer right here. When you're done with it, And here you justify each step. There's only one step here, and hopefully I'll help you out with this first one. N plus 3 equals -7. Here's my variable. I want to get rid of a plus 3. How do I get rid of a plus 3? That's going to be your justification step right here. I'm not going to tell you, but that's how you would get through it. Then after you get this one done, you finish the other 2 monitoring progresses. The best thing about this is, because you have some teachers that set this stuff up before I was even here, your monitoring progress is right here. I expect to see your work for monitoring progress in this when you scan your notes. If I see these are not done and then your monitoring progress isn't done, that's when you get calls home, and that's how your grade will drop. Remember how I said your effort level? If you give me an effort, your grade will be there. If this is not done, you're not giving an effort. It's that easy. We don't have to argue about it. I'm not going to argue about it. This is how I'll know if you gave me an effort or not. Okay. So you'll finish the monitoring progress on your own, and then we'll come back and then we're going to look at a new core concept. And that's what I'm going to pick up in the next video. So right now, go ahead, work on those monitoring progresses, and thank you very much.